So here are your notes where you're answering the question, how does the force and mass of an object affect its acceleration? Your notes are going to look a little bit different today. You're just going to have the essential question at the top, and then at the end of your notes, you'll answer the essential question at the bottom. If you're an Avid and you want to make these Avid style notes or Cornell style notes, you absolutely can, but you don't have to. So the first thing I want you to do is to title your notes, of course, if you haven't already done so, Newton's second law. And the reason why these notes are a little different is because we're going to do a think and write. Some of the things you'll copy down, some of the things you're just going to listen to the question, and then you're going to write your thoughts. And so pay attention to my instructions so that you know what to copy down and what to not copy down. The first thing I do want you to copy into your notes is a picture that looks something like this. So you're going to have a picture of somebody pushing a shopping cart, and this shopping cart is empty, and this person is pushing a shopping cart that's full of stuff. So we would consider this to be a larger mass than this one because it's full of groceries. And then this arrow represents the vector of the force that's acting on the shopping cart from the person. When you're done copying those two things, you can pause if you need to. I want you to answer this question. Do not copy this part down. I just want to think about it. So which of these carts would take the most force to make it accelerate? I want you to just think about that for a second and then defend your answer in a complete sentence. Would it be the cart that's empty, or would it be the cart that is full? After you answer that question, here's another question I want you to think about. Which of these carts will accelerate the fastest? Defend your answer in a complete sentence. Again, do not copy that down. Just think about the question and write what your thoughts are. So this part you are going to copy down. You're going to copy down what Newton's second law states. After you compared the two shopping carts, the one that had more mass and the one that had less mass, maybe Newton's second law will make a little bit of sense to you. Newton's second law states that acceleration will increase when there is increased force. Think about that statement after you copy it down. And then I want you to write what your thoughts are. If I said that acceleration increases with increased force, what do you think that means? Pause this to write your thoughts. So here I have two shopping carts this time. They are both empty, which means that both of these shopping carts have the same amount of mass. But we have a boy pushing on the shopping cart and then a grown man pushing on the shopping cart. So obviously they have, according to our force vectors, different amounts of force on their same mass shopping carts. Well, in this case, the shopping cart is going to have a greater acceleration because this guy is pushing it harder. Here's what this statement means. This statement means that things go faster when you push them harder. When there's more force on something, acceleration increases, things go faster. So here's kind of a catch with Newton's second law of motion. You already know this stuff. We're just putting the science words to what you already know, because you know that if you push a shopping cart with more force, you're going to get a greater acceleration. Here's the next part of Newton's second law. Copy this part down. Newton's second law states that acceleration increases with increased force, but acceleration will decrease with increased mass. After you copy that down, think about what that means. What does acceleration decrease with increased mass mean? Write your thoughts. Here's an example of this. So in this case, just like our first picture, we have the same boy pushing two different shopping carts. One has more mass than the other, also represented by our arrows and the boxes here. And we can see that the acceleration is less when there is more stuff in the cart than when there is not anything in the cart. So acceleration decreases will be less when there's increased mass. This is exactly why the big guys on a football team are on the offensive line. They don't run as fast. If they have more mass, they don't go as fast because acceleration decreases when there's increased mass. Here's another part of Newton's second law that is really important for you to know. Sir Isaac Newton figured out that he could calculate how much force acted on an object if he knew the mass and how fast the object was accelerating. So in order to help us with this concept, we're going to create a FMA triangle. It works very similar, I shouldn't say similar, exactly the same as the DST triangle when we were learning about speed. The unit for force is newtons. Please write that down. The unit for acceleration is meters per second squared. And the unit for mass that you're going to see is either kilograms, or if the object is smaller, has less mass, you may see a unit in grams. So we're going to put this mathematical formula to the test and do a few problems. Here's what I want you to do to kind of just keep these numbers straight. When you see a mass, I want you to put a box around it. When you see an acceleration rate, we're going to circle it, okay? So here's a bowling ball that has a mass of 6 kilograms. And when it leaves your hand, it leaves with an acceleration of 60 meters per second squared. And the question is, how much force did you apply? Well, if the formula is force equals mass times acceleration, then we're going to have to take the mass, which is 6 kilograms. Please include your units. I'm just not doing it for the sake of time. And the the acceleration of the bowling ball is 60 meters per second squared. So 6 times 6 is 36. And then add your 0. So 6 times 60 is 360. Do not forget your unit. The unit for force is newtons. So whenever you're calculating for force, you would always change the unit to newtons. After you finish your force problems, please review your notes, then go back to the essential question and answer the essential question at the bottom of your notes.